The Open Systems Interconnection, or OSI reference model, describes how information from a software application in one computer moves through a network medium to a software application in another computer. The OSI reference model is a conceptual model composed of 7 layers, each specifying particular network functions. It starts with the physical layer, moves to the data link layer. At layer 3, the network layer, layer 4, transport, layer 5, session, layer 6, presentation, and finally, layer 7, the application layer. This model was developed by the International Organization for Standards in 1984 and is now considered to be the primary architectural model for intercomputer communications. By having this standardized model, we are able to reduce complexity, we're able to have a standardized interface across the board, it facilitates modular engineering, reduces costs, and provides a troubleshooting methodology. The first layer, the physical layer, is the lowest layer of the OSI model. It is concerned with the transmission and reception of unstructured raw bit stream over a physical medium. It describes electrical, optical, mechanical, and functional interfaces to the physical medium and carries these signals for all of the higher layers. An example of a device that operates at layer 1 is a hub. The second layer of the OSI model is the data link layer. The data link layer provides error-free transfer of data frames from one node to another over the physical layer, allowing layers above it to assume virtually error-free transmission over the link. To do this, it provides functionality like link establishment and termination, frame traffic control, and frame sequencing. This is the first layer with an address called a MAC address. And an example of a device that works at this layer would be a layer 2 switch. The network layer, also called layer 3, manages device addressing, tracks the allocation of devices on a network, and determines the best way to move data. It's focused on data delivery, and it provides connectivity and path selection between 2 host systems. It routes data packets and selects the best path to deliver data. This is the second layer with an address called an IP address. An example of a device that works at this layer is a router. A router performs packet forwarding based on destination IP address. The final layers, transport, session, presentation, and application, each have their own job to do as well. The transport layer provides message segmentation, accepts messages from the session layer above it, and splits the message into smaller units, if that message is already not small enough, and passes the smaller units down to the network layer. The transport layer is concerned with end-to-end connections. The session layer allows session establishment between processes running on different stations. It establishes, manages, and terminates sessions between applications. The presentation layer formats the data to be presented to the application layer. It can be viewed as a translator for the network. This layer may translate data from a format used by the application layer into a common format at the sending station, then translates the common format to a format known to the application layer at the receiving station. The presentation layer handles data formatting and representation. Finally, the application layer serves as the window for users and application processes to access network services. It provides services to applications like email and FTP. It's very important to understand how data is encapsulated and de-encapsulated through the OSI model. Data is handed down to the transport layer where a transport header is added. From that point, it is handed down to the network layer where a network header is added. Next, it is handed down to the data link layer where a frame header and frame trailer are added, and finally is turned into ones and zeros, digitized, and put on the physical medium. Let's use the example of data encapsulation while sending an email. As the data comes from the email application down through the layers into the transport layer, the transport header is attached to the data, and the data now becomes a segment. From there, the data is now passed down to the next layer, the network layer. At this point, the network layer will now stick on a layer 3 header. Once the layer 3 header is attached, it now becomes a packet and is sent to layer 2 for processing. Layer 2, similarly to the previous layers, is going to process the incoming packet and attach its own layer 2 header. It is then going to send the frame down to the physical layer. The physical layer is all about transmitting ones and zeros. It's going to digitize the signal and send it across the wire. Once the bits arrive at the destination computer, the reverse process takes place. The physical layer at layer 1 is going to accept the incoming bits and send them up to layer 2 for processing. At layer 2, we're going to interpret the header information. It strips off the layer 2 header and then sends the rest up to layer 3 for processing. Layer 3 is going to perform similar actions that layer 2 just did. It removes the layer 3 header and sends the content of the packet without the layer 2 and layer 3 headers, which is now called a segment, up to the next layer. We then strip off the layer 4 header and send that information to the appropriate process or application. Here's a summary of the OSI model. Please take time to review this information and learn the layers of the OSI model, as well as what types of PDUs are associated with specific layers of the OSI model. It's also important to know the functional responsibilities and different examples of applications that work at each layer. Most people try to memorize the different layers of the OSI model. Myself, I use an acronym that's Please Do Not Throw Sausage Pizza Away. It starts at the bottom and goes from physical, data link, network, transport, session, presentation, and application. Join me for the next lesson, Understanding the TCP/IP Protocol Suite.